Hello. In this problem, I want to consider the polynomial function given by f of x equals x cubed plus 2x squared minus 7x minus 2. I want to list all possible rational zeros, find all zeros using synthetic division, and find the y-intercept as an ordered pair. And then I want to graph. Okay, again, here p is negative 2 and q is 1. The negative doesn't really matter, so the factors of 2 are 1 and 2, and the factors of 1 are 1 and 1. So my p's divided by q's give me 1 over 1 and 2 over 1, which simplified means I can use plus or minus 1 or plus or minus 2. Okay, now let's look for the zeros. Again, to find the zeros, the easiest way to do this is to actually type this into the calculator. Yeah, you can use random ones, and you probably have a pretty good chance of getting the right one because of the possible rational zeros, but not always. So, go ahead and just type in x cubed plus 2x squared minus 7x minus 2. And then you can either graph it and look here, or you can go to your table, which is second graph. Now notice here that I have a 0 on 2. Well, there you go. So the only 0 I see here, oops, there we go. The only 0 I see here is 2, so I'm going to use 2. 1, 2, negative 7, negative 2. Bring down the 1, multiply, add, multiply, add, multiply, and add. So I've just proven that 2 is a 0. The problem here is that this, what I have here, is a quadratic, and that gives me x squared plus 4x plus 1 equals 0, and that's a quadratic equation. This cannot be factored, however, which means that I have to use the quadratic formula. So this gives me x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that gives me negative 4 plus or minus the square root of 16 minus 4 times 1 times 1, which gives me 12, all over 2 times 1, which is 2. And 12 is the same thing as 4 times 3, so that means that x is equal to negative 4 plus or minus 2 root 3 all over 2. Now notice that 4, 2, and 2 all share a common factor of 2. So dividing each of those by 2 gives me negative 2 plus or minus the square root of 3. Well, there you go. Those are the other two zeros here. Notice that this does not exist in this here because these two are these four are rational. This is an irrational with that square root of 3 on there. The 2 exists here, but this does not exist within here. Okay, so there we go. These are the zeros. We have 2 and negative 2 plus or minus the square root of 3. But the question becomes, as an approximation, what is negative 2 plus or minus the square root of 3? Well, just type in negative 2 minus the square root of 3 and click enter. So it's negative 3.73 approximately, or negative 2 plus the square root of 3, and that's negative 0.26. So about negative 3 3/4 and approximately negative a quarter. Okay, So I'm going to go ahead and graph those just so I don't forget. So negative 3 3/4, 1, 2, 3 3/4, which is somewhere about right there, and about negative 1/4, which is about right there. And I can also plot 2. Okay, there you go. Those are the x-intercepts, or the zeros in other words. Now for the y-intercept, I need to find f of 0, which means I plug in 0 for all these x's, which gives me negative 2. So my coordinate is 0, negative 2. I can plot that right there as well. And again, notice that this is degree 3, so it's going down to the left and up to the right because there is a positive leading coefficient. And also, each one of these has a multiplicity of 1, which means it crosses. So you're going down to the left and up to the right. So it crosses here, and crosses there. And so just kind of connect everything. There you go.